Oh, me again. This time not playing around with vehicles, playing around with a Raspberry Pi 5. So I got a Raspberry Pi 5 a while ago. This is the other one I bought. This is the 8GB version. I've put it into a case that would allow for a bottom-mounted hat drive. So I don't know if you can see in between there, but I've got a Pineberry hat drive with a 1TB PCI Express interface there. I've got a I don't know what the brand is of this fan, forget, but a nice cooling fan. I had the top-mounted Pineberry 1TB NVM on top with the active cooling from Raspberry Pi, but I found that it wasn't very good when really pushing it to its limits and overclocking it. So I went with this one. I've kind of modified it a little bit by just pushing it down a little bit. That's why there's a bit of damage there to these copper pipes. Just pushed it down just to make the height profile a little bit narrower. I basically use this as my little PlayStation 2 emulator and what's called RetroPie emulator as well. This is just a 3D printed case that I got off, I think it was Printables. I thought it was really nice, pretty cool. Took me a couple of goes, first time 3D printing, so it's not the nicest looking one. But anyway, what I was curious about, and those who've been watching my videos, I'm not very good at programming and whatnot. I'm more of a hands-on kind of guy, and when I used to play around with I still do occasionally, the Anki vector robots and stuff. What I was a bit surprised about was the Raspberry Pi 5 only comes in, and I'll try, so where is it? There it is there. Only comes up to a maximum of 8GB. Now the nice thing about the Raspberry Pi 5 is that, I guess it's got this thing here where it says what's fitted, so you don't have to turn it on, I guess. But I have watched some videos and they were saying that it's, I think Jeff was saying it's like a 0 ohm resistor, and it's there just for indication purposes. If it was there just for indication purposes, I'm not 100% sure what it actually does, because as you can see here, so this is, I've got the 4GB version. This is actually a 4K ohm resistor, and so this is the ground side, and this side here, which is all kind of parallel together, goes into the RP1 chip. Now, I don't know what it's there for, but in the configuration here, if it were if it was a nothing thing, then I don't know what will happen if you had to remove that. And so when you put power to the board and you measure here, this is 1 volt. You get 1 volt on this side. Now, I didn't want to take my other Pi out of the case, because it's kind of, I don't know if you can see in there, but I've still got I've managed to get the active cooler, modified it heavily, so it's giving cooling, just passive cooling to the memory chips and the RP1 and the other stuff. So I didn't really want to pull this all apart again, just to have a measure to see if the 8 gig resistor would be the same. Would it be 4,000? Because if it was 4,000 ohms, then it doesn't really matter where you put it. It will always be 1 volt. Or is it the case that when you have they don't come in 1 and 2, but if the 8 gig one is like, I don't know, 8,000 ohms, does it actually tell the RP1 chip that this is actually an 8 gig version board? But anyway, the reason for making this video was that, yeah, so this is the chip. This is a Samsung LPDDR4X memory RAM chip, and this is it here. You know, so it's 32 gigabits, and all these things, 200 fine ball array, you know, type memory chip, and fine ball grid array, I should say, fine ball grid array. And I was curious to find if I could do one better. Now, obviously, we know that there's an 8 gig one version, but doing some research on the actual processor, the 2712 processor can support up to 16 gigabytes of RAM. So I got thinking, what happens if I just install a 16 gig RAM chip that meets all the same specs? And initially that was very difficult because, you know, Samsung is, I would arguably say, maybe one of the best in this field. And the key is this 200 fine ball grid array, and that's very difficult to match up to get, you know, 8 gigs. Samsung obviously do the 8 gig version of this, and having a look on a Mouser and everything, I really couldn't find anywhere that I could do where I could come across something that was 16 gigabytes on 200 FPGA. And I kind of gave up. And then I came across Micron. Now this is, I think it's a new part, because I couldn't find it anywhere else apart from one website. And this is 128 gigabits, which is 16 gigabytes. Has the same speed. It's, you know, arguably a little bit less because it's not 4x. It's 200 ball. Now this LFBGA is what it's basically just a little bit thinner. The profile, you know, if we look at this, you know, that's the thickness of it. Of the Samsung one, which I happen to have right over here. This one is just a little bit thinner, slightly thinner, apparently. Which for this application, I don't really care. Doesn't bother me, so long as the little balls are the same, which they are, which is brilliant. And yeah, the bus width is all the same. Everything seems to be the same. The speed's the same. Doesn't go as low as the Samsung one. I think Samsung can go down to 0.6, which I don't really care. So theoretically, hardware-wise, it should all just, yeah, be a case of removing it and fitting the new one. Will it work? I don't know. I think I will have to change some of the, I mean, like I said, I'm not really a software guy, but I'd imagine some of the kernels or maybe some sort of firmware, you know, to see if it's, I don't think this Micron and the Samsung would be pin for pin. Well, I'd imagine they would be pin for pin, but maybe just not timing wise and stuff like that. So there'll probably have to be some sort of kernel or some sort of firmware that need to be flashed, and maybe anyone watching who knows how to do that might be able to help me out. Now, if it does work, this is by no means something that economically makes sense. because this to get this chip was it wasn't cheap, but this was more than the Pi 5 itself. So I guess the designers of Pi 5 obviously have a business to run, and in their business model they need to keep this under a certain price. They can't just make it the best. Where for me, price wasn't really a thing for me. It's more just what's the best I can make this little guy. And yeah, so basically if I can install this 16 gig RAM, can we make it work? And does it make the Pi 5 better? So yeah, this will be, that's the plan. So I'm going to use this tape, and I'll basically tape up the whole board here apart from the RAM chip, just to kind of give it some heat protection. I'll use a hot air gun and apply heat, soften it up, remove the chip, clean it up, install the new one, and yeah, I'll stop the video here. And so yes, I just kind of remembered, silly with me, this tape is actually called Kapton tape. Kapton is a very durable material. I think they used to use it in wires and stuff like that to protect the shielding, the outer coating of electrical wires. Anyway, like everything in life, preparation is key. So it doesn't look pretty, but basically I've covered this whole thing apart from the RAM chip I wish to get out with this Kapton tape to protect it from the heat and also the air blowing around. I found, I don't have a lot of experience with reballing and stuff like that, but I found if you don't use the tape, you might have like these tiny little resistors like this nothing resistor, memory resistor over here that can sometimes blow away from the heat. So we have to put just the right amount of heat in there, and once it softens it up, once it moves, and we can remove the RAM chip, then turn the heat off, and then we prepare the underside and clean it all up and make it ready for the new chip. And then then it's just a case of applying heat, making sure that the heat is evenly distributed, and normally when it's done correctly you should be able to kind of like just touch on the chip and it would kind of like move, and then the solder will then like allow it to only settle back into its position, and it will be over the little points, over the little balls, and you'll see that it will just kind of like, if you just kind of move it, it just kind of self-centers itself, and that's generally when you know that you've done a pretty good job. So I'll come back to you when I've removed it. All right, I have just removed the RAM chip right here. It took a lot of heat. It took a lot more than I anticipated. And I'd like to say this was the first attempt, but from my last video, here was a perfectly working Raspberry Pi 5 and I wrecked it. That'd be quite hard to see, but yeah. I just couldn't get it off, and I pried at it, and I was too afraid to go any hotter. So when I did get it off, I ended up pulling some of the pads off and just wrecking it. So I decided to use it as a bit of a practice board before I got another Pi. And yeah, you just need to add more heat, basically. So yeah, I've kind of wrecked a perfectly, was serviceable Pi 5. A little bit disappointing. However, it did give me you can definitely now see where those little memory resistors connect to on the RP1 chip. That little pin right there. Yeah, I don't think it actually does anything. I think it's just for show, with any luck. Anyway, yeah, a little bit sad because I've just received the other RAM chip, which is the 4 gig RAM chip. It's just a new one from another manufacturer. I think it's from Alliance Memory, I think. And I believe it's supposed to be as good pin for pin replacement for the Samsung chip, but yeah, I don't actually think it's going to be any faster. It says it is, but yeah, because it was quite difficult, and it probably will be pretty difficult to install it. Removing and installing it multiple times for the sake of this thing, I probably, if I install the 16 gigabyte chip on this one, and it's, you know, I'm happy that it's all actually connected and it actually turns on, I probably would just leave it at that. And with this other chip, yeah, that would be for a later date, because I don't actually think it's gonna, unless I can find in the documentation, in the data sheet, that this chip is actually faster than the original Samsung chip. Really the only difference between this chip is that it literally just come off the shelves, but I don't think it's actually any faster. Trusty old screwdriver. It's looking okay. Probably could do a little bit better. That little guy there. But that is definitely looking better than this one that I absolutely butchered. Yeah, I'm very proud of that work. Yeah, it's all about the heat. So that's good. So I just did a little test as well where I've powered this guy up and just to see what it will do. So I kind of had an idea if, you know, if I installed the new memory chip correctly. So powering it up without this RAM chip, but just the green light flashes 8 times. You get nothing on the display. I'm assuming that 8-time flash is, you know, some sort of failure message. I also tried to turn this one on and, well, yeah, the little light, it goes red, stays red, and then it again flashes 8 times. So maybe 8 times is like a fault code for RAM failure. And well, yeah, just the red light. Well, red light's pretty obvious, but without the RP1 chip, I can't imagine it having too many brains. But anyway, yeah, so fingers crossed when we install the new guy, it's actually going to do something. So yes, orientation of the chip is everything. So little, if you can see that little dot there, oh yeah, see that little dot on the chip there, that normally indicates chip position number 1. And that was the same as the one that I removed. But there's also, you won't be able to see it with the solder flux. There's a little white, thicker part of this white outline on the actual Raspberry Pi itself, which is an indication of where that orientation and position of the chip should be. So, yeah, let's do it. All right, the hot air gun's cooling down. It's done, I hope. Seems to be correctish. I definitely got it hot enough. Took longer than what I was anticipating, but I was a bit afraid of burning the board. It was definitely snapping back into place. So, yeah, fingers crossed. And moment of truth, Pi 5 with a 16GB RAM chip. And buzzkill. Well, it's not flashing green, which I guess means it's just not turning on. Push the button, nothing. Damn. Well, I guess there's some sort of kernel's firmware that must be updated. Alright, I'm going to try and reheat it just because the chip doesn't seem to sit evenly on both sides. As you can see, there's a little bit of a bigger gap there than there is that side. So I think and I hope that maybe if I just reheat it and get it to properly settle, we might be able to get somewhere with this thing. So the second attempt at the resoldering, just applying heat to the chip, failed. So I had to remove the chip and manually reball it. That's adding the little soldering balls without the stencils, as you can see, and then reapplying heat and getting the balls to reattach, as you can see here, and it worked out quite well enough to resolder it, and it all worked. So, to recap, I have soldered on the 16 gigabyte RAM, and I went onto the forum, the Raspberry Pi forum, just to get some help. I didn't, because all it was doing was, doing this error code flashing, which according to the Pi 4, this is flashing 9 times. It's very hard to count it exactly, so I end up filming it and doing it in slow motion, be able to count the dots. I mean the lights flashing, and it counts 9 times, and 9 times means, what does it mean? Insufficient RAM. So with that, I went on to the Raspberry Pi forum just to, I wanted to know whether my soldering was bad or if it just, there's a firmware issue and it just doesn't allow it to work. What I found was my chip that I bought, which is this one here, which to the original, this is another Pi 5 with a Micron chip in it, and it has the main difference that I can find with the chip I've put in and the one that came with it is this CAS latency programmable. The one I have doesn't have that option, so I'm not sure if that's something within the software that, changes. Sorry, that's not the one I bought. The one I bought is... where's the one I bought? The one I bought is... this one. I bought this one. So yeah, it's a 1.1 volt, not the 0.6 volt, and it's a non-CAS latency programmable. Anyway, from the forums, some guys really helpful have given me how I can debug this thing. So yeah, I didn't really have a connector, so I kind of just put some the transmit receive connectors in the ground, just using what's already out in the Pi world there, this document here about how to connect it, the debug, and just using real term, I'm pretty basic. But yes, so it looks like, as you can see here, that my soldering is good, which is great. But yeah, so you can actually see the actual read the error. So boot error code 9, SDRAM size not supported, and it actually comes up there. It can read it, knows the manufacturer, knows the size. So yeah, I guess to make this work, or must be something to do within the firmware that we can try. But yeah, I don't know how it all kind of fits together inside there, whether the memory controller can actually it's just not possible. There must be a reason why the Raspberry engineers said that, even though that we know that the processor can take up to 16 gigabytes of RAM, must be the actual board itself doesn't seem to accept, well, just won't be able to take that large amount of RAM. Well, maybe it can, maybe it's just a firmware thing, but it would be strange that why they wouldn't have the option. Anyway, yeah, so there you go. Okay, so this is the final setup. my Pi 5 with 16 gigabytes of RAM. As you can see in there is the Micron chip. And if you punch that code into the website, you'll see that that will come up with the particular model. That code there is what I'm talking about. So you punch in that code, it will come up and say, yep, this is a 16 gigabyte version, which is the programmable one. So this is my little setup I have. Little cooling tower with, put some thermal paste on there. I've just connected up the UART debug, because yeah, you can't actually, when you see when I plug it in, it doesn't actually do anything. I have this little real term connected up, so let me see if I can do this with one hand. I'm not going to be able to. So if I just yeah, anyway, I'm going to plug it in. Sorry about this. As you can see there, you've got the green light for the 1 terabyte RAM. 1 terabyte what you call it? PCI drive there, which is pretty cool. My plan is to use this as like a home server. And as you can see here, this is the output. So that flashing 9 times is an error code 9, or boot error code 9. SRAM not supported. And as you can see there, size is 128 gigabits, which is 16 gigabytes. So yeah, I have a brick of a Pi, and I'm hoping at some point in the future someone out there might be able to help me how I can reprogram the firmware to allow me to what's the word, I guess, bypass this unsupported memory size and just try it anyway. My understanding is that the CPU can actually handle up to 17 gigabytes of RAM. But yeah, it's obviously all just theoretical. And I'm hoping somehow I can either reflash the firmware, if someone's able to give me one to try. I'm a little bit concerned obviously with just trying any old one and then soft bricking the device. Don't really want to do that either. I really just want to have it working, or at least just bypassing this, you know, unsupported size and just trying and seeing what happens. But anyway, as you can see, it doesn't boot any further than once it gets past that little once it does the initialization of the RAM, which is like one of the first steps. It then just, yeah, stops. So the CPU, I don't even think is turned on at this point. Fan isn't even running. So it's pretty much a dead device. Cool. Anyway, took a lot longer to solder it and everything like that. I bought a second Micron just because I yeah, messed up the first one, which is a little bit annoying. And I also have another Pi 5, which I also put a Micron one, but this was a slightly different model. This one was the 1.1 volt non-programmable version, but it still comes up with the same error. So yeah, I think this was just a more energy efficient version. So yeah, I've got two Pi 5s with 16 gig of RAM and I can't use them. Yay for me. Anyway, hopefully someone out there or somewhere in the future, the Pi engineers will be able to put a firmware update that will remove that lock. And yeah, have a Pi 5 with 16 gigabytes of RAM.